Okay, my pre-cal people, this is about residuals. So this is the second video about residual plots. So what you need to remember about a residual plot is we want to have random residuals, right? We want our residuals to plot to a random thing, not a pattern thing. Okay, so part of this assignment that you're going to do is investigating and seeing that sometimes you get patterns, and it's actually pretty neat that it comes out to be like that. Okay, so we're going to first start by doing our regression lines, and we're going to do a cubic regression line for this. Okay, now it might help. It might help if you start at time 0. Okay, so if you're going to plug this into your calculator, you can make that time 0 and this time 1. Okay, you can do this with any set of data that you want to that is a time-stamped data. Okay, so there are 10 pieces of data here. So if we call 6 a.m., right, we call 6 a.m. times 0, right, that might give us a nicer cubic regression line than if we started at midnight being 0. Okay, so I'm going to put this in my calculator, and then I'll snap a picture of it to see what it looks like. So there is our data in there, and now we're going to use our calculator. So we're going to hit menu and do our statistic calculations, and we want to do a cubic regression line. So when we ran a cubic regression with these values as your x's, and then of course your car values as your cars, this became my cubic equation. Okay, this is my x cubed coefficient. This is my x squared coefficient. This is my x coefficient, and that's my y-intercept, or my constant. So if you use 6 and 6.5 and 7 and 7.5 like the data said, in your actual data right here, if you use these values, then you probably had a slightly different equation, which is perfectly okay, right? Because you're going to write down the equation that you have over here so that we can actually do something with this. So let's write the equation. My equation from my data that I put in is 0.023x cubed minus 1.028x squared. I'm running out of space. Plus 8.28x plus 10.136. Okay, so that's my equation that I get from using the data of 0 through 9 as my times and my cars going through there. So if you use 6 to 10.5, then of course it's going to be different because your y-intercept is going to be different for 1, right? Lots of things can change if you use different x values. But use whatever you put into your calculator, right? It's correct if you do that. So now let's look at the residuals, which is also on our calculator. Okay, let me take a picture of what I have. So this is another box, right? It says resid here, telling you that these are all of your residual values, which are the difference in between your data points and what the calculator calculates using that equation. Okay, so it does a whole bunch of equations. It just did 10 calculations, and then it subtracted them. And these are, so this is my first residual, this is my second residual, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. There are 10 of them here, so I'm going to put that into my box that happens to be here on my screen now. Okay, my residual values. We're going to put all those in there. So we write down all of those residual values, right, that your calculator have done for you into your table. Right? I want to see these because you need to know, I want you to know where they come from. Okay, because our last thing we're going to do is actually plot them over here on your graph. So let's take our residual values and let's plot them on your graph right here. Okay, and then we're going to look at what your plot looks like in the end. So there are all of my residuals, right? I plotted them all on my grid. And if I were to connect these with some dots, right, you don't have to, but with some straight lines, right, there's not really a pattern at all. Some are positive, some are negative, some go up and some go down, right? That's good. That's what we want to have, okay? So our final question, is this a good fit, okay? So the answer would have to say yes, but we're going to be specific. On the interval from 6 to 10.5, right? Was that our time frame from 6 to 10.5? Yes. So between 6 and 10.5, right, from 6 to 10.5, our equation is really appropriate, right? The cubic regression is appropriate. So yes, it's a good fit, but then our residual is talking about the appropriateness. So only from 6 to 10.5, right? After this, we don't know what's going on, but on our interval for our given data, this equation that we wrote, this cubic, is pretty stinking good. Okay, it's pretty appropriate in order to model this data. So let me show you what the graph looks like. So here are all of my data points, right? And this is my cubic equation that I'm using to model that data point. Remember, the residuals is the difference in between your actual data point and the calculated point. Okay, so there's some are above, some are below, right? It comes out to be random when you plot them together. Okay, which means that this equation is appropriate for our time frame. Right? If we were to look at other time frames, it might not be appropriate. But for what we have now, this is pretty good job. Okay, so that's how our residuals, the plot of a residual, can help you decide if your equation is appropriate for your data or not.